Hello and welcome to this Autodesk manufacturing webinar. My name is Clinton. I'm joined today by my good friend and colleague Rob. And in the next 45 minutes, we're going to discuss manufacturing software and reflect on whether your current software is actually meeting your needs today. And more importantly, if it's evolving fast enough to meet these changing needs in future. Now, throughout, we're going to be focusing on Autodesk Fusion 360. That's one of our many manufacturing products. And we're going to showcase its impact that it's having on manufacturers like you. I'm going to pause here briefly. We're not planning on discussing any future releases of Autodesk products, but if we do mention ongoing development plans, please bear in mind that these things can change. And so you should take this into account whenever you're making your buying choices. Now, we have a packed agenda today. We'll start with a quick introduction before reviewing some of the top trends that we see in manufacturing. We'll look at some common operational challenges that businesses like yours need to overcome and spotlight potential outcomes that you could achieve. We'll introduce Autodesk Fusion 360 and explain what it is, what it does, and how it works. Rob will then walk us through some scenarios to explain how Fusion 360 can be used, and then I'll showcase some of our most inspirational customer stories and explain how they're achieving positive outcomes with Fusion 360. We'll wrap up with a short summary, give you some learn more opportunities, and finish with a live Q&A. So remember that Q&A button at the bottom of the interface. Send your questions at any time and we'll answer them at the end of the session. Now, before we get going, a little bit about the two of us. So hi, I'm Clinton Perry.
And hi, I'm Rob Walker.
Now, despite our marketing titles, we both come from engineering backgrounds. We came to Autodesk through the acquisition of Delcam. Now, I've been with Autodesk since 1995. This is actually my 27th anniversary this month, next week as it happens. And Rob has been with the company since 2004. Now, we're both part of the team responsible for marketing Autodesk's range of manufacturing software products, and clearly that includes Fusion 360. Okay, so now you know a little bit about us. Let's continue by considering the major trends that are affecting manufacturers today and show how these really represent opportunities for growth. Now, we're certainly in turbulent times. Manufacturers around the world are understandably concerned about geopolitical unrest, financial volatility, and the lasting impact of a global pandemic. There's a lot of doubt and uncertainty in the market, but at the macro level, three things are clear. First, there's a big skills shortage, the likes of which we've never seen before. Now, by 2030 in North America, 2.1 million manufacturing jobs will be vacant. And it's a similar story in Europe, with more than 500,000 jobs already unfilled in the manufacturing sector. Likewise, supply chain disruptions continue, which makes it harder to get products to market, but it's also making it harder for you to source spare parts and new equipment. And then finally, the cost of goods continues to rise, which makes it harder and more expensive for you to source raw materials and component parts. Now, the upshot of all of this is additional pressure on your team to deliver goods quickly, whilst minimizing costs, avoiding mistakes, and controlling waste. Now, the good news is that this level of disruption also creates opportunities for all of us. Now, in a static market, the incumbent suppliers are next to impossible to displace. But every now and then we experience major events that change the natural order of things, meaning those that can adapt fastest quickly become the new leaders. And we believe that now is the time to reimagine possible and to use this time of disruption and change to do things better. So for manufacturers like BBI Racing that you see on my screen now, finding ways to control costs, maintain margins, fix supply chains, upskill people and attract young talent means that they're better positioned to win market share today and grow their business tomorrow. Now, what do we mean when we say reimagine possible? Now, there are many trends that you can take advantage of right now. For instance, more and more industries are being transformed by smart products. This makes machine tools around us more productive, but it also creates opportunities as consumer demand grows, product developers expand, and supply chains onshore. Manufacturing processes themselves are increasingly becoming digitized, which provides greater flexibility and efficiency from the tools that you use. And cloud technologies are changing how we manage our supply chains and the manufacturing processes we use, helping us to deliver our products on time, every time. Now, when you hear smart products, you probably think of an iPhone, a Nest thermostat, or maybe a Tesla. And that's certainly true in the consumer product space. But in recent years, we've seen more industries embrace smart technology. And it's playing an increasingly important role on the shop floor too. Take, for example, smart hardware controllers from companies like Datron, One Click Metal, Haas, Mazak, and many others. These all represent the bleeding edge of smart manufacturing, and we expect to see this trend expand and accelerate across the rest of manufacturing. And it's not just products that are digitizing, it's also the processes we use. Milling, turning, probing, welding, cutting, and 3D printing all provide a wealth of data for analytical purposes. But those processes aren't used exclusively. You use multiple processes to make your products. So it's a big problem when you have to use multiple software products to define and control your manufacturing processes. And the situation gets way worse if you need to start making changes. So we believe that manufacturers like you want, in fact, they probably need a flexible platform, one that can accommodate design, simulation, milling, turning, fabrication, additive, and production management, all with data at the center of what you do. And recent events have shown the challenge of connecting people and suppliers to this data, something that manufacturing has traditionally struggled to perfect. Now, we recognize the need for a flexible platform, one that can connect all aspects of the manufacturing supply chain, ultimately helping you to adapt faster. Because investing in the right digital manufacturing solution can make the difference between winning and losing new business. And yet, despite all of these demands, manufacturers around the world still accept an old, antiquated experience. Multiple software tools with incompatible proprietary file formats, poor data control with files being shared by email, wasteful manual processes and disconnected workflows, and a mix of digital and analog information. This all impacts your ability to work effectively, increasing the likelihood of mistakes, delays, and lost business. And so, as manufacturers, we need to address these challenges, and we aspire to achieve 4 key values: to create better products, win more business, improve your operational efficiency, and finally, to enable increased innovation. So at that point, I'm going to hand over to Rob, and he's going to dig into a little bit more detail about common operational challenges. Rob, over to you.
Thanks, Clinton. Okay, so clearly there are many macro elements that might be affecting your business, but we also commonly see a lot of operational challenges and obstacles within manufacturing ourselves. Now, these can collectively prevent you from achieving those key values that Clinton's just mentioned. Now, of course, you will have your own unique challenges, but the most common we see are the constant need to keep up with design changes and automate to reduce delivery times, the need to maximize CNC machine usage and improve the quality of manufactured parts, all whilst trying to manage resource consumption and address the skills gap, which Clinton mentioned earlier. So let's look at these in a little more detail. Now, first, we have the need to cope with design changes. Now, design changes can be costly as they can delay production. But how are these changes communicated? What happens if a design change is not communicated before production begins, and what's the cost of this? Now, the right software can help by simplifying the design revision process with seamless associativity between design and manufacturing. Now, this provides a direct link so that your teams are always up to date with the latest versions. And this can be reinforced through effective communication methods, which inform stakeholders of design updates. By overcoming this challenge, you can then improve your collaboration across your organization. Now, next, there is a need to automate to speed up manufacturing processes and reduce delivery times. But what do we mean by automated? Now, automated within the manufacturing industry comes in many forms, from assembly lines to industrial robots to the automated guided vehicles or AGVs. But for this presentation, we are focusing primarily on software solutions to help automate the processes of design and manufacturing. Now, automation helps you reduce non-value added processes, and you can deliver repeatable and consistent workflows which improve quality and reduce human error and will ultimately result in more reliable products. Our next challenge comes from the CNC machine usage in your facility. Now, whether you have existing machines or you are purchasing new ones, it is important that you maximize their usage in order to maximize the return on investment in them. Now, this can come in many forms, from the automation of the setup process to start machining sooner, to utilizing multi-axis capabilities that reduce the number of setups required and minimize tool lengths, and then through to in-cycle probing for verifying part accuracy during production, which maximizes uptime and reduces waste. Again, the key is software that can produce safe, predictable NC code for CNC machines to enable lights out manufacturing, and ultimately improve your manufacturing throughput. This next challenge is inherently linked with the previous ones, where the need to improve part quality goes hand in hand with machine utilization and can be aided by automation. Now, quality issues can have an adverse effect on profitability. Now, this can be through the need to perform costly rework or manual processes such as polishing. And if not rectified, these can affect the reputation of the business, which in turn affects repeat custom. Now, to improve part quality and consistency, again, we use software. In addition to the points made on the previous slide, like probing and multi-axis machining, manufacturers need advanced options to finely control their output of their machines and processes, such as toolpath smoothing, additive build simulation, and grain orientation for sheet-based fabrication. By improving quality, you can reduce the defects and non-conformities of your process. The next challenge comes from the consumption of resources. Now, when I say resources, this could be anything consumed across your business, such as the materials you use, the energy required to process them, and the people, time, and money that's involved in production. Now, reducing your usage of resources has a direct effect on the bottom line of your business, but it also has an environmental impact. Simply put, if you use less, you reduce your carbon footprint, which boosts the sustainability of your business. Now, by looking at ways to better manage your resources, you can reduce both consumption and environmental impact. Now, the sixth and final challenge I wanted to talk about comes from the need to fill the skills gap. Now, the skills gap is something that has been widely spoken about, but fundamentally comes down to the gap between the number of skilled jobs available and an apparent lack of skilled people that are able to fill these roles. Now, part of this problem is down to an aging workforce, which once retired takes a lot of craft and skills and knowledge with them. Now, this is difficult to pass on, so capturing this knowledge is vital to maintaining the skill levels within an organization. Therefore, we might look to software that can help capture this knowledge and store it for use by others within the organization, allowing best practices to be shared and collaboratively refined later. This brings us back full circle to improving collaboration again. Okay, so clearly there are a whole range of operational challenges, and based on the poll, we can see that these are affecting a lot of you, quite obviously. So to think about is how those range of operational challenges can be overcome. So you need to overcome them in order to achieve the success within your manufacturing business. Now, you may have a range of outcomes that you are looking to measure, which in turn provide those values to your business that Clinton mentioned earlier. So, for example, you might be looking to improve your manufacturing throughput. So this can be done by finding ways to produce more output in a given timescale. If so, it is likely that you will be looking to reduce the non-value add tasks in your processes to remain productive. And being productive means creating good quality parts, so reducing defects and non-conformities is a must. Now, if you reduce defects and non-conformities in your production, it will scrap fewer parts and will therefore reduce the consumption and the effect on the environment. And if you improve collaboration across your organization by connecting people to your data, your workflows and manufacturing processes that they use, then you can speed up the process to get from design to manufacture, improving your time to market. Now, each of these outcomes could stand on its own, but they are also invariably linked to each other, and they are triggered by overcoming the challenges I just mentioned. So choosing the right software technology therefore can help you overcome these challenges and achieve your outcomes. Now, the ideal result being that you are able to make more parts, make better parts, and use less resource making them, which brings us neatly to Fusion 360.
Thanks, Rob. Yes, let's talk about Autodesk Fusion 360. What is it? What does it do? And how can it help your business achieve the outcomes we've just been talking about? Now, before we explain what Fusion is, it's probably easier to start with what it isn't. So Fusion 360 isn't just a PLM system. It's not PDM, MES, or CAD. It's not just CAM or simulation, documentation, rendering, or electronics. It doesn't just focus on additive, milling, fabrication, or turning. It's not one of these things. It's all of these things. Now that makes Fusion 360 fast. Fast because its modern app-style interface and user experience slashes learning curves. We're talking days, helping you to become productive faster than many outdated products that are on the market today. It's fast because it uses cloud-based technology to connect your people and your suppliers to your data, your workflows, and the processes that you use. And it's fast because it provides automation tools to remove non-value add tasks to help you make better products with fewer button clicks. And this focus on speed supports your business and ultimately allows it to grow and succeed. And Autodesk continues to invest in manufacturing, having already spent more than $1 billion in our software solutions in recent years. We continue to add capabilities into Fusion 360 by developing and acquiring and investing in technology, including advanced manufacturing from our investment in Delcam, mold simulation from Moldflow, NC code post-processing and verification from Camplete, and manufacturing execution from ProdSmart. Now, unlike many traditional manufacturing software products that offer annual updates, we release a major update to Fusion 360 every 8 weeks. Now, this means we're able to provide our latest technology and react quickly to customer needs when they arise. And this is reflected in the growing number of commercial subscribers to Fusion 360, with more than 1 million monthly active users today, which is an amazing achievement. And in the last 12 months alone, we've accelerated development, providing more than 300 major updates and enhancements, many of Rob is going to talk about later. Now, we have a growing and vibrant online community of users and followers on social media, with tens of thousands of active forum members who regularly help and inspire each other each and every day. Now, we're proud of where our users have taken Fusion in the last few years, and we're even more excited to see how it grows and evolves in future. Now, before Rob walks us through some real-world examples showing how Fusion can deliver value to you, a gentle reminder to use the Q&A button in the Zoom interface to submit your questions that you might have. And with that, Rob, back to you.
Thanks, Clinton. Okay, so going back to that need to address the challenges then, we can look at the outcomes and see how Fusion 360 can help your business achieve them. And we start with ways in which you can improve your manufacturing throughput by reducing non-value add processes, using automated programming tools to enhance manufacturing processes, minimize waste, and improve consistency. Now, embracing automation within your manufacturing processes can have a huge effect on your manufacturing throughput. Now, manufacturing throughput can be increased through the use of automated programming tools in Fusion 360, such as hole and pocket recognition. So profiles can be detected and programmed automatically, automating decisions that would have previously been made manually. What's more, by automating, no matter who is programming, the resulting output can be the same, allowing flexible changeovers, improving result consistency, and ultimately component reliability. Now, manufacturing knowledge and best practices can be stored as templates and shared with the entire manufacturing department to automate programming. So this helps less experienced members of the team become more productive sooner, bridging that skills gap and improving programming consistency. Taking this even further, intelligent automated toolpaths like steep and shallow tackle the finish of freeform surfaces, automatically detecting the surface geometry and applying the optimal strategy to different model regions. Now, steep and shallow provides a 4-in-1 toolpath, meaning that as well as the combined toolpath itself, it can also be used to access individual operations with a range of options to control toolpath angles, wall clearance, continuous spiral motion, cusp removal, and smooth offsets, all of which are designed to help achieve the best possible surface finish. There are also additional toolpath smoothing options to help tailor the point spacing to better suit your CNC controller, reducing the need for manual rework and improving your manufacturing throughput even further. Now, complex high-value parts often contain features and details which cannot be produced using 3-axis machining alone. Now, this is why Autodesk Fusion 360 offers or creates simultaneous multi-axis operations to fully utilize the 5-axis capabilities of multi-axis CNC machine tools. And when the part complexity increases further, automatic collision avoidance can be used to provide an optimal tool axis solution. This all provides better workpiece access, allowing the use of shorter, more rigid tools for improved surface finish and a reduction in the time spent on multiple setup parts. And automation is not just limited to CNC machining. So for fabrication processes, automated nesting will automatically detect component material thicknesses, distributing the appropriate numbers of parts into different material sheets, removing the time-consuming sorting processes from your workflows, and reducing the time it takes to get from your design to cutting the pieces ready for fabrication. And automation can even be used within the additive manufacturing, with the automatic creation of additive support structures. So these reduce the time it takes to get your parts printed. Okay, so there are many things that can be done to reduce non-value add processes and increase throughput. But what if we want to manufacture parts with the same or even increased demands on quality and accuracy? So if that's the case, then we must look to reduce defects and non-conformities in our processes, which in turn will reduce the resource consumption and reduce environmental impact. Now, linking back to the previous section, automating your setup of your part is a key area for reducing defects and non-conformities. Now, here we have a comparison between a manual setup and an automated sequence on the same part. Now, in both cases, the time code at the bottom right of each video indicates the time taken, but note that the manual video is running significantly quicker than the automated setup video. Now, even for an experienced operator, this process is difficult and time-consuming to do manually, and is especially true for large, heavy, or non-prismatic parts. The result is that the machine is sat idle and not cutting parts, which eats into profit margins. So by programming setup sequences online and running them as quick, repeatable, and accurate NC programs, profitability can be maximized as machine time can be better utilized for production rather than wasted through workpiece setup. Now, even in this simple example, the manual setup takes over 15 minutes, whereas the automated setup takes just 2 minutes and 40 seconds, representing an 82% saving in time on the machine. So to reduce defect and non-conformities, using an automated setup process becomes an obvious choice. Now, the integrated environment of Fusion 360 means that part setup, programming, and verification on the machine are unified into a single user experience. This lets you quickly and accurately set up and check stock material and parts on the machine and create the required toolpaths without leaving the Fusion 360 environment. Now, geometry features such as hole sizes and channel widths can be measured. The results are then reported against tolerance, where adjustments in toolware can be made for subsequent operations to improve part accuracy. And the same technology is also used for part verification without taking the part off the machine. So this allows part accuracy to be checked before moving to subsequent processes or final inspection. Any unexpected variation can be detected and remedied immediately, minimizing costs and improving efficiency. Product manufacturing information, or PMI, which is defined at the design stage, can also be imported into Fusion 360 as well. Now, this can be used to help check that the parts you manufacture have the correct dimensions and tolerances and that the designer defined, with the ability to input measurement values manually using devices like height gauges, micrometers, calipers, and so on, to record that your parts conform to the design specifications. Now, excess material can be efficiently removed using adaptive clearing. Now, this proprietary algorithm optimizes feed rates as the engagement angle of the tool is maintained throughout the cut. Now, this shortens the overall machining time since the full flute length of the tool can be used, but it also increases tool safety and decreases tool wear, reducing cutting tool consumption. Now, the modification of calculated toolpaths can also be performed, such as splitting toolpaths, or perhaps deleting unwanted segments and passes, replacing tools for things like better clearance, and also the movement of start points. Now, all of which can be done crucially without the need for full recalculation. So this saves programming time, which is a precious resource. And when it comes to sheet materials, automated nesting can be used to quickly identify physical material properties and then efficiently lay component pieces out to maximize the available material. Now, the key thing here is we're reducing waste and subsequently environmental impact. Multi-axis positional machining drives towards both outcomes by reducing the cost of fixturing as parts are produced in fewer setups, streamlining manufacturing processes. And since that part remains on the same machine setup for most of the manufacturing process, you maintain tighter tolerances between features as compared to using a multiple setup process where errors can compound quickly. And whilst additive shouldn't really be forgotten, build simulation can reveal potential defects, allowing parts to be corrected before sending to printing. And lastly, but certainly not least, is machine simulation. Now, machine simulation helps you verify your machining processes in a digital environment, providing the opportunity to analyze, identify, and rectify toolpath processes before they get to the machine. Now, this provides confidence that your machining processes are helping to prevent any costly collisions and reducing the chance of scrap parts and allowing your machines to be productively producing parts, not repeated dry runs. Okay, so finally we come to improving collaboration and improving time to market. Now, the manufacturing team is just one part of a larger business, so it's important that this team can collaborate both easily within itself as well as the wider organization. Now, fortunately, Autodesk Fusion 360 was built to support flexible dynamic collaboration workflows through the utilization of a cloud infrastructure. Now, when a design department releases the latest design, the manufacturing department can get to work quickly, accessing that model data from the cloud to prepare and program for manufacture. Now, program toolpaths and fixtures are stored on the cloud too, along with tools, post-processes, setup sheets, and even NC code, allowing easy access to the data as a team needs to work effectively and efficiently. Now, this data can be accessed from anywhere, from PC, Mac, or mobile, and shared through team access or through simple links with download and password options, allowing full control of data access. Now, since this data is hosted in the cloud, external collaborators can be given secure access too. So this is using Fusion 360 Team Participant to upload, download, view, mark up, and collaborate on projects. This seamless collaboration streamlines project management, allowing issues to be quickly addressed, improving communication, and helping avoid costly delays. This ultimately improves the level of service users can provide to their customers, increasing the likelihood of repeat business. And because everything is hosted in the cloud, everyone is working on the latest data. So programmers can share their setup sheets with operators. Operators can update cloud libraries for programmers. Designers can communicate design changes to programmers, and assembly teams can receive instructions on fixture assembly. And this is all quickly and easily within the cloud. So by using Fusion 360 and Fusion 360 Team Participant, seamless collaboration workflows can be unlocked to keep teams connected, whether they're across the hall or even across the world. Now, Fusion 360 integrates powerful and easy to use modeling tools alongside its intuitive manufacturing tools. And because the design and manufacturing tools are integrated into the same environment, this means you're able to go from design to machining faster. Now, additional elements such as hole caps, extension surfaces, and so on can be added to aid the manufacturing process. And fixtures and work holding models can be created from your own design or brought in from a range of samples and quickly included and positioned within your Fusion 360 file to hold your parts accurately and safely. Importantly, though, if the original design changes, the associativity of Fusion 360 means that work-holding fixtures, nested parts, setups, and toolpaths will all update seamlessly, reducing the risks associated with change orders and letting the manufacturing department be more productive. Now, the associativity even extends to third-party data because Fusion 360 lets you collaborate and manage CAD data with anyone, regardless of the CAD software that they're using. This removes the need to translate their data while still maintaining a link to the original CAD file. The result is that any updates to the original third-party file will also be reflected in Fusion 360, And so design associativity lessens the impact of the issues caused by design revisions, improving your time to market. And lastly, there's additive prototyping. So speeding up the process to get you from concepts to on the screen to the reality can realize through additive manufacturing. Fusion 360 supports both plastic and metal additive processes with modeling tools to make parts print-friendly and a host of tools specifically made for additives such as support structures, creation, and build simulation. Combined with subtractive manufacturing processes, prototypes can be rapidly created, improving your time to market. So probably a lot of questions on your mind is, how is this technology within Fusion 360 accessed? Well, Fusion 360 uses a flexible access model. So to illustrate this, let's look at a simple diagram. Now, Fusion 360 delivers a range of capabilities within a core offering, which includes CAD modeling with 2D drawing, 3D solid and assembly modeling, computer-aided engineering with cloud solvable mechanical and thermal simulations, CAM programming, including 2D, 3D and positional multi-axis or 3+2 machining, and workpiece coordinate system probing. There are additive capabilities to support plastic additive fused filament fabrication or FFF, fabrication tools for sheet-based production, electronic tools for PCB design workflows, and cloud-enabled collaboration to help your teams do what they do best. Now, layered on top of that, we offer Fusion 360 extensions at an additional cost. Now, these unlock additional advanced capabilities within the same Fusion 360 interface with different extensions serving the needs of both designers and manufacturers. In today's presentation, we've been focusing on both the core functionality and the extensions relating to manufacturing. So how would this work across a manufacturing business? Now, your organization might look something like this, or it might be completely different. But for illustrative purposes, in this example, we have offices and we have a shop floor. Now, within the offices, there is a design team, perhaps creating products or designing fixtures for manufacturing, and perhaps a team of part programmers responsible for programming all of the machines on the shop floor. On the shop floor itself, we might have programmer operators running 2-axis lathes and 3-axis machines. And perhaps we have more complex multi-axis machines, or maybe fabricators using routers, lasers, water jets, and so on. And we might even have an additive manufacturing need, so perhaps a research and development team, or even using additive for production. Now, in this scenario, every member of the team can be given access to Fusion 360 if they need it. The low cost of entry and core functionality of Fusion 360 means that it is more than capable of meeting the needs of much of this business for design and manufacture. Now, if more advanced functionality is needed, for example, addressing the need for simultaneous multi-axis machining, then the appropriate extension can be switched on, such as the machining extension for the programmer operators on the shop floor, or the part programmers in the office responsible for programming all of the machines. And this is without the need to install additional software. Now, the same mechanism is adopted across all users, but crucially, access to Fusion 360 extensions is totally flexible, meaning you can choose which ones to activate based on your business needs. What's more, extensions can be accessed for a single day, a month, or a year. So if you have short-term projects that would benefit from extension functionality, like the need to automate whole part machining strategies, or surface probing for castings in 3-axis machining, then an extension can be switched on to satisfy the needs of that specific project. And perhaps even more importantly, they can be switched off when the project is complete. So the choice is yours, meaning you only pay for what you need when you need it. Lastly, and significantly, we have the data at the center linking everything together. Now, with everyone connected through the cloud to Fusion Team. This means that regardless of whether your team members use the extension or not, they can all access the same data on the cloud, allowing them to collaborate and share things such as CAD data, tool libraries, fixture assembly, setup sheets, and more. Everyone can access the data they need and analyze it for their specific use. And it is this mechanism that is used, for example, by experienced users to share projects and programming templates with the other programmer operators to help bridge that skills gap, and how CAD model changes are associatively linked to their appropriate manufacturing processes downstream. Now, this improves collaboration and also helps when we think about suppliers. So access can be given to your suppliers, speeding up delivery times and improving your time to market.
So we've covered some great capabilities there. Rob's done a great job of showing the potential business benefits that Fusion has to offer. Before we start wrapping up, I'd like to showcase a couple of customers that that are really showing how they're using Fusion 360 to achieve the outcomes that they look to set out. And we're going to start with the world's largest sports equipment retailer, Decathlon. And for many of you, I'm sure you've been there many times and love the place. Now, it was founded in 1976 in Lille, France. Decathlon is truly unique, though, in its space, as it manages the full research, design, production and distribution of its products through a global network of more than 1,600 stores. The company holds three key values at its heart: performance, price, and a respect for the environment. Now, balancing innovation with mass production can be challenging. I'm sure you all have first-hand experience of that. But innovation is a core part of the Decathlon culture, as is their commitment to reducing carbon emissions, having made a commitment to reduce by 40% per unit sold by 2026. Now, the Decathlon engineering team decided to embark on a project with its bike brand to explore the bike performance, or the performance bike of the future. Now, most performance road bikes are made from carbon fiber, a material that is both high in strength and low in weight, but also wasteful to produce and very difficult to recycle. The engineers decided to use Fusion 360 and its design or generative design and additive manufacturing capabilities to 3D print the frame and forks in metals locally and on demand, slashing weight, reducing carbon footprint and making it recyclable too. And ultimately, Fusion 360 is playing a central role in helping Decathlon to change the very nature of what they do. And as Charles Cambianagicha, Advanced Design Project Leader at Decathlon, proudly states, the Fusion platform is allowing them to create products that have less environmental impact and more emotional impact. Moving on to Conturo Prototyping, founded in Pittsburgh, Pennsylvania in the US in 2016, this specialist contract manufacturer uses CNC machining and additive manufacturing to deliver short production prototype runs to a growing list of aerospace, robotics, and medical customers. The company's unique selling point is its ability to meet the tightest of specifications and deliver finished parts quickly, allowing their customers to shorten their overall product development times. Now, the very nature of prototyping means that the Conturo team must be able to adapt to the ever-changing challenges that they face. With such a diverse range of projects, the flexible nature of Fusion has been central to the business success. They invested in Fusion 360 and the machining extension to make better use of their 3- and 5-axis CNC machines. And they did this by unlocking capabilities that Rob has covered before, including automatic part alignment, multi-axis machining, and automated hole and pocket milling. All this allowed the Conturo team to offer a higher value service to its customers, and this saw the business grow rapidly, allowing them to increase their overall shop floor space by a factor of 17 in just 6 years. And ultimately, Fusion 360 has helped the Conturo team to differentiate itself, reducing its costs and winning more business. And as Patrick Fee, shop manager, states, Fusion is such a great value that it's paid for itself in the first few weeks and the very first project. And finishing with Detroit-based Ganas Manufacturing. Founded in 2015, this custom millwork and bespoke furniture manufacturer serves both residential and commercial clients. It prides itself on combining traditional craft skills with precision machining to produce exceptional installations. But the company recognized the need to improve its production process to overcome some long-standing issues: poor material utilization, costly human error, a lack of process consistency, and delays caused through rework. The company invested in Fusion 360 and the nesting and fabrication extension to design and manufacture their products using a range of 3- and 5-axis routers, and the results were huge. First, they saved time and materials using automated nesting, reducing typical waste per project from 25% to 5%. Secondly, they automated repetitive tasks, removing laborious and error-prone processes where every nest had to be calculated and cut by hand, replacing it with an automated solution using predefined templates that delivers predictable results every time. And finally, reducing scrap and rework by removing the need for manual data input, which eliminated human errors and gave the team confidence that their machining process is 100% right every time. And investing in Fusion 360 has freed the Ganas team, freed them from worrying about production problems and allowing them to focus on designing and delivering highly efficient products with perfect fit and finish. And as Richard Ganas, the owner, states, Fusion has played a central role in the business achieving many of its outcomes and overcoming those legacy production problems. So let's start wrapping up with a quick summary and some guidance as to what you can do if you'd like to learn more about Fusion 360. And one final reminder, if you've got any questions that you want to submit, please use the Q&A button now and we'll ask them shortly at the end of this session. So to summarize, today we've discussed some of the biggest trends in manufacturing and considered how operational challenges actually represent opportunities to do better. We introduced Fusion 360 and explained how its cloud-enabled and fully integrated CAD and CAM capabilities is helping manufacturers like you to unify your manufacturing onto a single platform and ultimately reimagine your new possible. Now, if you remember at the beginning of the call, I asked some rather challenging questions. I asked, is your current manufacturing software delivering on its promise? Is it really meeting your needs today? And is it evolving fast enough to meet these changing needs in future? I'm hoping some of you have probably answered no. And if that's the case, then maybe the time has come to say goodbye to outdated, disconnected, inferior manufacturing software and say hello to Autodesk Fusion 360. Now, you might be wondering how much all this capability costs, but I prefer to ask it in a different way. How much is it worth to your business? For many, you could already be paying in excess of 20,000, 30,000 euros for equivalent technology from other software suppliers. And often this consists of a large upfront payment and ongoing annual fees that restrict your business from growth. But Fusion's different. With prices starting from as little as $545 per user per year, it's accessible and affordable. And as we've seen, it provides additional value through a range of extensions for designers, for manufacturers, and for those needing more advanced data management tools. And let's not forget, access is flexible with annual, monthly, and daily options, meaning you only pay for what you need when you need it. And for those wanting to achieve even more value, you might be interested in our Fusion 360 for Manufacturing offering. This includes all the extensions you see listed here, with the added appeal that it costs up to 55% less than if you were to subscribe to the extensions individually. Now, before we move into Q&A, I'd like to suggest 4 things that you might like to consider doing after this call is finished. If you'd like to learn more about Fusion 360 and its capabilities, or if you'd like to try Fusion 360 for yourself completely free for 30 days, including access to those extensions we mentioned before, or if you'd like to talk with an approved Autodesk representative in your country, or if you'd like to buy Fusion 360 now. Whether you want to learn, try, talk, or buy, scan the QR code that you see on screen now, or visit the website that you can also see on screen, and we can help you reimagine your new possible. So again, thank you so much for joining us today. I hope you found this presentation both educational, inspirational, and we hope that you have been moved to consider Fusion 360 as a solution for your manufacturing business. Thank you once more. Goodbye.
Yes, thank you. Bye-bye.